How can we find the Fourier transform of the integration of a signal with respect to the time t? So we want to find the Fourier transform of this integrated signal. Well, it will be opposite to the differentiation. In differentiation, we multiply by j omega. Integration, we divide it by j omega. That's the first thing. And then we add here like initial condition plus pi x when omega equals 0 multiplied by delta omega. We are going to use this property to find the Fourier transform of a unit step function. All right. So when you think about it, you say, okay, I want to use this formula, and the unit step is given here. So I ask a question. What is the signal if I integrate it? I get unit step. All right. You can think about it in the opposite way. Say, what is the signal, what the result signal when I differentiate the unit step? Well, it will be obviously impulse. And at 0, because here is the change. So at 0, you will have impulse, unit impulse, delta t. We know something about the unit impulse. Negative infinity to infinity, the integration of delta t dt is equal 1 if you integrate from everywhere. And if you remember, because we did like approximate the delta as a small rectangle, which is the area is equal to 1. So that's why when you integrate it, be equal to 1. But let's just get a little bit in detail. If you have the unit impulse at 0, or taken a little bit, like from minus 0.001 to plus 0.001, anyway, and if you're going to integrate it till time t and time t a little bit less than 0, you are going to integrate from negative infinity up to time t, which is less than 0. So what would be the integration? From negative infinity to t for delta, now we are going to change the variable from t to tau because we are integrating to t. So the integration of the impulse delta of tau, the tau from negative infinity up to t, where t didn't get yet to the pulse, that would be equal 0, because all this 0 before that. But if you have the pulse at the same position at t equals 0, and you're going to integrate from negative infinity, from here, negative infinity, up to time t, and the t will cross 0, greater than 0. So what will be the integration when you integrate from negative infinity up to t when t is greater than 0? Remember, this one when t less than 0, and this one we're going when t is just bigger than 0. Again, other. So the integration from this side till the time less than 0 is equal 0. But once you cross, so you are going to include the integration of the impulse, which is equal to 1. So in this case, the integration will be equal to 1, because you included the area of this impulse. So now you can say that the integration for the unit impulse from negative infinity to t has two solutions. It depends where is t. If t less than 0, the result is 0. If t greater than 0, that will be equal to 1. So now if you hide this a little bit, you hide this integration and look at that. What is the function that's 0 when t less than 0 and 1 when t greater than 1? It's unit step. Let's sketch it. When t less than 0 is equal to 0, that's 0. Greater than 1, 1. That's it. That's unit step. So, as true. So the unit step is equal to the integration of unit impulse. That's great. Now we can use the property of the integration. we'll find x of omega and divide it first by 1 j omega. All right. So what is Fourier transform of delta? It's the easiest one. It's equal to 1. So Fourier transform of unit impulse is equal to 1. Now I'll apply the rule. I'm integrating only one time here. So u of t will give the Fourier transform using the integration. I just have to write it again. 1 over j omega x of omega plus pi x when omega equals 0 multiplied by delta omega. Okay, let's continue. What's x omega is equal 1? So it will be equal to 1 over j omega, and x omega is equal to 1 plus pi x 0. But what's value of x is 0? It's equal 1. Equal 1. It's equal 1. Because it said the Fourier transform is equal 1, all right, for this delta of tau. So it's just constant everywhere. So 1 delta omega. So it's equal 1 over j omega plus pi delta omega. What is that? That's the Fourier transform of the unit step. So that's an important application. Help us to find Fourier transform of the unit step.